Okay, next we're going to talk about receiver operating characteristics curve, or called ROC curve. ROC curve is a very important topic in classifying methodologies. ROC plots have two lines. One line is for the classifier and second line is for naive classifier. Okay. So what is naive classifier as opposed to a regular classifier? Naive classifier is one where you classify all the observations as the majority class. So you take a look at the data set and you have the target and there is zeros and ones, right? Event and non-event, zeros and ones. Now if there are more zeros than ones, then the naive classifier is that you classify all the records as zeros. On the other hand, if there are more ones than zeros, then you classify everything as one. So your prediction is the majority class for the target. So that is your naive classifier. Now whatever classifier methodology that you may use, it has to do better than the naive classifier. If you can't do better than naive classifier, then that classifier methodology is useless for you. You might as well just use the naive classifier. So that's the general principle. So what we're going to graph is on the y-axis you will have sensitivity, okay, from the confusion matrix. The x-axis will be 1 minus specificity. Okay. So what we will do is you compute these two values for various cutoff probabilities. So starting from 0 to 1. Okay, in increments of say 0.05 or 0.1, and then you compute at each of the cutoff points the value of sensitivity and value of 1 minus specificity, and then you plot that. Okay. So let's go to Excel and then let's look at how to set this up. Okay, so we have our example of the Warner.df, so that's your riding lawnmower example, and we have the data along with the ownership, and then we have the predicted values of the probability. Okay, we already saw this last time. Now remember, these probabilities are, we are assuming that we have these probabilities, and usually you will have to run a model to generate these probabilities, and you will have one for training set and one for validation set. And here let us assume that this is the validation set, and we have somehow computed these probabilities using some data mining model. Okay. So right now we have the confusion matrix with 0.5 as the cutoff probability, and we have set up the confusion matrix table using countifs and countifs function. So if you change the cutoff probability, all of these numbers will change and all of the probabilities will also change. So for example, if you put 0.4 there, and you'll see that these numbers change and the accuracies and everything change. Okay. So to develop our ROC chart, okay, so we're not going to do this accuracy measures, we'll skip over that. And here, okay, so we need to set off a bunch of cutoff points. So let's start from 0, and then say we add 0.05. Okay, so previous value plus 0.05. So if you copy that, then it will increment by 0.05, and let's go all the way up to 1. So we're going to now try all of these different cutoff points, and at each of these cutoff points, what is the value of sensitivity? And we really want 1 minus specificity, but let's do specificity as well. So we've already set up the formulas at the top, so let's go there. So that's our sensitivity. Okay, and then if you copy that down, then the next row is specificity, and then 1 minus that is 1 minus specificity. Okay. Now we're going to set up a table with sensitivity, specificity, and 1 minus specificity, right? Okay. So now we're going to run a data table where we will use all of these different cutoff points, and for each of those cutoff points we want the data table to show these 3 values. Okay, so start from here, okay, highlight that range, and then data, what if analysis, data table, and the probabilities are in a column, so this is a column input cell. So its data table is going to get the probability values from this column. And where do you want to put it? You want to put it here. So when these range of probabilities are inserted here one by one, the value of sensitivity, specificity, and 1 minus specificity will get, this table will get populated with those values. Now for the ROC chart, we want to plot sensitivity on the y-axis and 1 minus specificity on the x-axis. So we start from row 99, so this one is not part of the table. So the table starts off from here. Okay, click that, and then we go to insert. Okay, so we can select one of these, so let's select that one. Okay, so now that one plots only the sensitivity on the y-axis, so we have to select the chart and then click select data. Now edit. So now I have the y values from sensitivity. Now the x values must be starting from row 99 up to that. Okay, so now we have the ROC line for the methodology that gave us those probabilities. Now we need to add to this the naive method. Okay, and naive method will go from 0, 0 to 1, 1. So that line is 0, 0 to 1, 1, right? So select this chart, go to chart design, select data, and then now add the second. So the X series is that, and then the Y series is that. Okay, so now we have the ROC chart. And we don't, okay, let's format this. We need to go only from 0 to 1. We do the same thing with the y-axis. We got 0 to 1. Okay. All right. So now, how good is this ROC chart? So if this orange line is the naive method, right? So we have to do better than the naive method. So the ROC chart should be to the left. The farther it is out to the left, the better it is relative to the naive method. Okay. So if you have a perfect ROC chart, okay, so what would it look like? Okay, the perfect ROC chart will look like this. Okay, this is what? This is 1 minus. Okay, let's this is 1 minus specificity is plotted on the x-axis, and this is sensitivity. So a perfect classifier is one, okay, that will classify all the non-events as non-events, and it will classify all the positive events as positive events. Okay. So as you change the probabilities, okay, or cutoff point probabilities, okay, so you should have 100% clarification in terms of specificity, meaning that all the non-events are classified as non-events. So there will be 100% specificity. Okay, all the different probabilities, you will have 100% specificity, and then after a certain point, then you will have 100%. All the events are now classified as events. So you have 100% sensitivity. So for all the cutoff probabilities, you either have 100% specificity or 100% sensitivity. So 100% specificity would mean 1 minus specificity will be 0. So you will have a curve going like that and like that. So that is a perfect chart. So if you look at this is our current ROC chart. Okay, now that's your perfect ROC chart. Okay. Now the question is, how do you know how good a particular ROC chart is? Okay, so how good an ROC chart is? So if you go back to this one, you see that the farther out, so this is the perfect. So the farther out the current ROC chart is from the diagonal, the better it is. Okay, of course, the best being completely here. So the one way of assessing how good a particular methodology's ROC chart is to look at the area under the curve. Okay. Now, if you take this area, the entire area as 100%, okay, and now we have the naive classification method, so that goes diagonally, so that covers 50% of the area in the box. Okay, so the ROC chart, okay, the farther out it is from the diagonal, the better it is. So the closer it is to the diagonal, then it will be the area under the curve for the ROC chart will be closer to 50%. But it can't go below 50%. At least it has to be 50%, because if it goes below 50%, then you can always do the opposite of what the methodology is saying. So if the methodology says classify as 0, then you just turn around and classify it as 1. And if the methodology says classify as 1, you just turn around and classify as 0. So you get a mirror image of that, and then you will have the ROC curve will be on this side and not that side. So the minimum possible value for the area under the curve, so it's called AUC, is 50%. So the farther out it is, the closer it is to 100%, the methodology is that much better than the naive method. So let's go to R and then see how to set this up and how to calculate the AUC values, area under the curve.